Hello, my name is Tomoyuki Hoshino. I'm going to talk about design of optical triplexer with cascaded MMI couplers and waveguide crossing with offset. In recent years, optical communication has become widespread, and the number of FTTH service subscribers is increasing year by year. Therefore, the system using wavelength division multiplexing is required. In Japan, an optical triplexer is used to demultiplex 3 light waves. We have investigated a polarization-independent optical triplexer that consists of cascaded MMI couplers and one waveguide crossing. The structure is more simple and more compact than currently used. The figure shows that the structure of a polarization-independent optical triplexer. The light wave at 1310 nanometers is coupled to the output 1. 1490 nanometers is coupled to the output 2. And 1550 nanometers is coupled to the output 3. In this time, I'm going to talk about waveguide crossing and MMI4. When using original type of waveguide crossing, crosstalk will occur at the crossing area. Therefore, to reduce crosstalk, we take advantage of offset at crossing area. In this paper, I launched 1550 nanometers TE mode from input 2. The amount of offset is 0.33 micrometers. The angle of waveguide crossing is 14 degrees. MMI coupler is a microscale structure in which light waves can travel, such that the optical power is split or combined in a predictable way. I researched how long is the length of MMI couplers in which the optical power of output 1 is strongest when I launched 1490 nanometers TM mode and optical powers of output 2 is strongest when I launched 1550 nanometers TM mode. Next, analysis result. First, waveguide crossing. These figures show that the polarization of light wave in the waveguide crossing. This figure is original type, and this figure is offset type. And this table shows the comparison of polarization loss at output waves. The lower the polarization loss at output 1, and the larger the polarization loss at output 2, the closer the result that I want. The result shows that you can suppress crosstalk by taking offset at crossing area. Second, MMI coupler. When I launched 1490 nanometers TM mode, and the length of MMI coupler is 169.5 micrometers. The optical power is 0.941 at output 1. When I launched 1550 nanometers TE mode, and the length of MMI coupler is 251.6 micrometers, the optical power is 0.935 at output 2. The results show that these lengths can obtain the largest optical power as the desired output waveguide. Finally, conclusion. A polarization-independent optical triplexer composed of cascaded MMI couplers and one waveguide crossing has been proposed. The results show that one offset type waveguide crossing can suppress crosstalk, and there is optimum length of MMI coupler for each wavelength and polarization state. Thank you for listening.